Let's continue working with planes in 3D. It's been a few weeks, but the concepts are the same. Let's see how these three planes interact. Here's the system we will solve today. Solve the equations and give a geometric interpretation of the solution. So we are not just solving algebraically, we want to see how the planes relate in 3D space. Remember, in three variables, each equation represents a plane. A solution xyz is a point, vector, lying on all the planes simultaneously. So geometrically, planes can intersect in three ways: one point, a line, or no intersection. Let's visualize this using the Desmos 3D calculator. I will enter the equation one by one. The first equation, 2x minus y plus 4z equals to 5. This is the first plane, color red. Let me move it around for you to see. Let's say I take away the xy plane. So you can see that this red wall intersect the x-axis and the z-axis at a point. And also the y-axis if I make it a little bit smaller. The second equation, x plus y minus 2z equals to negative 3. This is the second plane, color blue. The red and blue planes intersect along a line. Let me show you. The third equation, negative x, negative 4y plus 10z equals to 6. This is the third plane, color green. When we look at all three planes together, do you see a single point where all planes meet? Have a look. Do you see a single point? Looks like they don't intersect at a single point. Now, let's confirm this using the CASIO FX cg50 graphical calculator. Go to Menu, Run Matrix, select Matrix, and the definition. Create a 3 by 4 augmented matrix. The 3 by 4 augmented matrix is 2, negative 1, 4, 5, 1, 1, negative 2, negative 3, negative 1, negative 4, 10, and 6. These are all the coefficients of the tree system here. So the dimension of this matrix is 3 by 4, 3 rows and 4 columns. Step 1, eliminate x from row 2. multiply row 1 by negative 1 over 2, and then add it to row 2. This gives the new row 2. Choose row op, and then hit on multiply row plus. On the screen, you will see k times row m plus row n, arrow row n. Enter k as negative 1 over 2, m as 1, and n as 2. Execute. Next step, eliminate x from row 3. Multiply row 1 by 1 over 2, add it to row 3. Choose multiply row plus as well. Enter k as half, m as 1, n as 3. Execute. Step 3, eliminate the y from row 3. So we will be using row 2. Multiply row 2 by a suitable number and then add to row 3. Using multiply row plus as well, can you tell me what's supposed to be k, what's supposed to be m, and what is n? Okay. Row 2, multiply by 3, add to row 3, new row 3. So k is 3, m is 2, n is 3. Enter this into the calculator. Execute. And now we come to the last row, which is 0, 0, 0, negative 8. This represents 0, x plus 0y plus 0z is negative 8, which is impossible. So the system has no solution. Let's go back to the plane. Geometrically, this means the red, blue, and green planes do not intersect at a single point. Here is a challenge. If we slightly change the first plane, could all 3 planes meet at a point? Try in Desmos and share your thoughts in the comments. Let me give you one suggestion. If you change 4z to 1z, meaning the first equation is 2x minus y plus z equals to 5, will you get 3 planes meet at a point? Let me know in the comment.